Let's get started. So today, what we are going to do is we are going to add a custom texture to your mesh. Of course, in the future, it should be your own image. And then what you can do is you can populate anything that can capture the color, and you can use the color value to make some decisions. And then, for example, now with this method, you can actually move this geometry anywhere, and the geometry, the object will still capture the position, and you can see that they are also capturing the color. Not. Okay. At least it captured the first initial color. Let's see. Okay, so let's start from a new scene. Let's just start from new scene. And everybody has a terrain model. So I'm going to bring that in. So I'm gonna bring my sample site model. I'm going to put it in a 0, 0, 0 position, but you can actually put it in pretty much anywhere. It doesn't really matter. But I'm going to just make sure that I am generating in this bounding box, and I have no structure, no texture. And if you are importing FBX, make sure that you delete all the camera. And this one doesn't have any texture. And also, when you are importing something, make sure in the model you enable the read and write. All right. And make sure that this, because this is completely squarish, so I created a texture in Photoshop, and when I make my image, I created like 1900 by 1900 pixeled image. So you want to make sure that your ratio is exactly following the geometry, so it's actually matching exactly with the details. And let's say it's just an image. It's just an image. So what I'm going to test now is I just downloaded, I just captured the map from the Eagle Mountain, and it's not precise. So you will have much more precise texture. But I just, for the sake of demonstration, I will just grab some area from this very bad Google map, and I will just make this into a texture, then show you as a demonstration. But of course, if you have a matching texture and mesh, that will be perfect. And say export, save as a PNG or JPEG. In this case, I'm going to save as JPEG, and sample map texture. Then I saved it. Of course, a little bit of high resolution will be helpful, but don't have to go too high. All right, so once you have it, you can make a folder called image, or I have this folder called material, so I'm gonna just put it here. Drag this image into here, and I'm going to just I'm going to create a new material. Right click material and say name it terrain material, terrain map, something like that. And I will apply this one to this material. All right. And if you, of course, if you change color here, it applies, but we are not going to change color per se. We wanna drag this sample map texture to the texture here. So if you just drag it here or click on this dot, so and you can search for the texture map, and you can apply this texture here. Of course, mine doesn't look very good because it doesn't match, but it's okay. So that's how you can just change, apply a texture to a material. And one thing you want to do is you want to go to the texture, and in the inspector, you want to enable read and write, because you want to read the texture information, okay, pixel information. All right. Okay. So once you have this ready, we are going to, so I'm going to save the scene before I lose anything. So terrain color, whatever. Yeah. So I made it for terrain color and apply. Of course, you need to apply the changes to the image. And then I'm going to right click, create empty, reset, and we are going to do very similar exercises last time, but we are going to do it from scratch, so you can all follow along, even if you don't have, even if you just start from complete scratch, you can follow. Okay, so what we are going to say is city generative city. Okay, that's a very great idea for a name. And then make a script called generative city again. And we are going to double click to open it and hook this up to generative city empty object. All right, now we are ready. Okay. And in the prefab, I have a simple prefab, the one that we made before, but I'm not going to use that. I'm going to just make 2 new prefab just for demonstration reason. So for now, I'm going to create a cube. I'm going to make it slightly bigger and reset to center and make it around 5, 5, 5. So it's 5 meter by 5 meter by 5 meter big. So it's around the house size, right? And I'm going to also make the lighting setting, render lighting setting, turn the real them off, generative lights, everything's white, okay. Turn it on, okay. And this is a cube house. Cube. Okay, that's okay. Then I'm gonna make this as a prefab, and now we can delete it. And we are going to make a sphere just to you can add anything. This is just for demonstration purpose. I'm going to make 2 different geometries, and this is a sphere. I'm going to name it sphere house, and I'm going to move it to here and delete it from the scene. Okay. And I'm going to populate this on somewhere on the sky above randomly. We have done this before, so I'm going to go do that very quickly. So first of all, I'm going to delete these comment lines. It's redundant. And I'm going to bring the public game object building or house prefab 1, public game object house prefab 2. And we also need to bring game object terrain mesh. Okay, save. As it's public, it's going to be a requirement from here. So the first prefab, I'm going to put cube. Second one, I'm going to put sphere. Third one is the terrain. So make sure that it's this thing, not this thing, right? So you can also unpack this, bring it out, delete the parent, and change this to terrain mesh. And drag this one into the terrain mesh. Okay. All right, now you are ready. In the start, we are going to populate. So we already know how to do that, so I'm going to do this very quickly. We are going to for loop int I is 0, I is smaller than 20. I'm going to populate 20 of them, I++. And inside here, we are going to initiate the first house object. So in order to initiate, you need to declare current house object is instantiate. So not initiate, instantiate the first house object. This one, if you want, you can just copy from the previous exercise. And we need a position and rotation. Position vector and rotation vector. And we have to declare it, and on this transform and a parent. So the position is a vector 3. Position is a new vector 3. We need to put them on a random dot range minus 80f to 80f. And the height will be, for me, I make sure that it's high above your terrain model, because this will get a like down direction to search for the geometry. Okay, so make sure it's higher than your terrain model. So for me, 35 is good enough. So I'm going to populate it there. And then random range minus 80f, 80f. And the rotation is a quaternion. Rotation needs a quaternion dot identity. This is a default quaternion. So this is a way to populate 20 housing objects. So Control S, and let's populate it. Okay, so that looks really good. So you can also, like what we did before, we can give different conditions for different things. But for now, I'm going to just produce this many objects to start with. So are you here already? Do you need a few minutes for typing in? All right, so this is how much we populated it, and today the method we are going to use is something called Raycast, and because we have created them and put it inside this generative city parent, we can search for them again by using int I is 0, I is smaller than this, transform child count I++, to actually search for all the populated boxes, houses. All right, so this one we are going to give condition a little bit later. Just for now, we are populating the geometries. Okay. And then what we are going to do is we are going to get each of them and do something about it. So the first thing is the current house is this transform get child I game object. So this means I am looping through all of this one by one, and when I'm calculating them, I call it current house. And I'm going to declare a position, vector 3, current position to be this current house dot transform dot position. So I'm going to use the current house and just for now make it into a shorter name. This equals this. So because we are going to use this to do some calculation. All right, and what I'm going to do here as a diagrammatic explanation, I'm going to shoot a ray from each of these boxes, like, you know, like laser. Yeah, so we're going to shoot one ray from each of them and find where I am hitting. And then you can actually return the position of where you're hitting this ray and the color where you're hitting this ray. All right?
Can I ask one question?
Yeah.
So does it contain the gravity? So when it falls down, if it's like a slope or something?
It's not physics.
Oh, I see. Okay.
It's just shooting a ray to look at it and finding the position and color and different information of the mesh.
Got it. Thank you.
Okay, good question. Okay, so this is not about movement, it's about searching. Okay, so that's why we need a ray direction. So Raycast, it's called Raycast, and we are going to name it as a Raycast direction. So this direction is up to you to decide. We are going to shoot a down direction. But in the future, if it's a wall, you can actually shoot like with different directions. But now we are going to create a vector called down. And this vector is actually returning a, you can see, it's a short stand of writing vector 0, -1, 0. So it's creating a -1, 0, -1, 0 vector. We are going to make it a little bit longer. So we are multiplying around 100 to make sure that they are long enough to hit our geometry. And then the thing we are going to use is called Raycast hit. For this, we have to create something called hit. And this will store all the information of the thing that we hit it. Okay. And then there is something called ray. We have to create this thing. It's a new ray for ray, you need a position, which is the current position, and a direction, raycast direction. And this will create a ray. And for the sake of debugging, we can actually display this. So I'm going to just use this debug draw ray. And it needs a start and direction. So start, of course, is current position, and direction is raycast direction, right? And you also need a, you don't have to have a color, but you can also add a color. We are going to put a color green for now. We are going to change this color later to the one that you are shooting. So let's play this, save it, and play it. And this is not really showing any ray. Direction. Why is it not showing? Okay, let me. Okay. That's okay if, oh, because we didn't call the raycast. Okay. So we didn't let it cast anything. So we have to call, we have to create a collider. I'm going to call it call, and we are going to use our terrain mesh to create the collider raycast. Say get component collider. And this, we are going to create raycast from this thing. But the thing is, our terrain mesh doesn't have a collider. So you have to go back to our Unity scene. And in the terrain mesh, we need to add something called mesh collider. So if you type in mesh, there is this thing called collider. Yeah. So for the purpose of this exercise, we should not tick anything here. So we are not going to use convex collider, just leave it like this. Now this terrain has a collider which can be read from here. Okay. So once you have this collider, we can actually collider, say raycast, and we can use ray and just follow this format: out, raycast hit, and a float of maximum distance. So I have to say out hit, and the maximum distance, I will just put something like 200 just to be safe. Let's see if we can run this. Okay, this is still not showing. Okay, so we are going to say if. So what this does is it creates a, it returns a Boolean value. So it tells you if I have a raycast, if I'm hitting a raycast, hitting an object or not. and just put this one inside the if condition. So let's see if this will draw anything. Draw rate should show. Still not showing. Okay, let's not worry about that. Why is it not showing? Okay, so this is not, this is okay, don't worry. Let's use different color. Black. Because of different display method. Down and times 10. Okay, so basically just for example, I wanted to show this thing. So that's array. So that's something it's shooting. It's a vector that is shooting down and search for the hit. All right. And I don't know why this is not showing there.
Is it possible if the mesh collider doesn't contain the right mesh? Like now it's default. Is that the problem? No.
Mesh collider.
Yes. Is it possible to have a wrong mesh?
Wrong mesh.
Putting in, it says default. I have no idea.
Oh, I don't think so. I don't think so. But let's just go ahead, yeah, to see if it actually searches. Okay, this is just still just drawing. It's probably won't affect how it's searching. So okay, let's go ahead. What we are going to do is we are going to use the current position. And say current position will become my hit point. Okay, and current transform dot position. Oh, sorry, don't worry about this. Just say current position is hit dot point. So what this is doing is if this is successful, then it should search for the hit and find that position and refresh my position to that. So after this line, it should snap to the geometry. So if it snapped, yeah, so it's working. It's just the display was not working, but it's actually snapped. So did you get to this point? Yeah. Okay. All right. So this is actually pretty good. If you do this line in update, it's going to keep on searching for the new position. So just for the purpose of this, you don't have to do this. I will just do quickly to show you. I'm gonna Control X, Control V. I will paste it back and then save it and play it. And now if you move it, okay, it's gonna show when you start to move. Okay, so it's actually finding the position and it's actually keep on following your mesh. Do you see that? Okay.
Yes.
All right. So yeah, it displayed somehow when it starts to move. Okay. But if this is in the start, it's not going to refresh. Yeah. But we are not going to deal with this movement yet, constant update yet. So we are going to go back here. And now what we are interested in is to get the texture color. All right. There are a few lines that we need to do. So we have to get a renderer. So it's called renderer. And we are going to call it rend. And this renderer is coming from the geometry that we hit. So hit, transform, get component, and renderer. What is this renderer refer to is this mesh renderer. This mesh renderer has a texture from this terrain map. All right. So we also need a mesh collider, which we already have. Mesh collider. We are going to call it mesh call to make it simpler, and then say hit collider as mesh collider. So we are converting our hit collider into mesh collider. And then we are going to create a texture 2D, texture 2D. We are going to call it text. This texture is coming from the renderer, the material, the main texture as texture 2D. In the future, you can just copy paste these lines. Don't worry about each and every line because I also found it from some forums and tutorials, and that's how it's set it up. So we need also a vector 2D vector to kind of get the pixel information. So we are going to make a pixel vector. We are going to call it pixUV. And then this is coming from the hit texture coordinate. So that's the key. So we are getting the coordinate from the hit. And we are going to convert this x, multiply the x to the texture's width, because the texture's width can be anything. So multiply the height to the texture's height. Okay. Now you can actually get the color as call. We call it call, and the color is get pixel. And we are going to get the pixel information from these two information. So we are going to convert the first pixel ID from a float to int. This one from float to int as well. Then now what we are going to do is we are going to, instead of using black, we are going to use this color information. But this was not updating, so let's see if this is
Exactly.
this is actually showing. Okay, so it's not showing here. So for now, we are not going to use it as a ray display. We are going to change the color of the object to the pixel image. So in order to do that, we are going to say, okay, current house dot get component mesh renderer, and this one has a material with white material. I'm going to change its color to be the pixel color that I get from this. So just these few lines were about getting the color from below. So all of these lines are happening in start. Okay, so that's it for grasping color. So let's say play, and they're all getting the color from below. Yeah, and that's actually how you can get the color information. Okay, but just